If you already watched my video about electromagnetic induction law completion as J here, there is something that I missed in that video. Here I want to fix about my missed part, that force because of magnetic field that affect to moving charge is equals to this equation, which here if we have wire that has J factor that proportional to QV factor, if there is external magnetic field which is not generated by J, we will have force as this. Here, the force because of magnetic field perpendicular to external magnetic field that again perpendicular to the velocity of moving charge, which is these three perpendicular each other. And by wire illustration, velocity always parallel to J factor here. So by this illustration, the equation above is correct, but equation in my induction law video and some concept explanation are wrong. So here we have full Lorentz force set, and if we take the infinitesimal charge, we will get this. And by taking the first derivative of force with respect to charge, then we get this equation, which this result relate to some kind of force that felt by overall dq charge partition. And next, we took counter integral for loop C, then we will get that the result of this integration is work of all dq felt because of force. And then the equality will become this. Fun fact, this part we can see as epsilon capital here, which here relate to commonly known as electromotive force or EMF. So that means the definition of electromotive force, well actually it's not a force, is about work to move each charge along closed loop C. So that's why we need to define the force over Q, because we want to determine the force and then work that fell to each partition of charge along the circuit.